Welcome to lesson 6. You've survived this far. Let's keep going as you work through adding whole numbers. The concept in itself should not be difficult. It's something you've been doing for quite a long time. However, there's some terms that we want to make sure we understand as we go into applications about addition and adding whole numbers. For example, as you look at the 3 problems on the board, we have 3 plus 4 plus 7, 7 plus 4 plus 3, or 4 plus 3 plus 7. You notice that all 3 problems have the same 3 numbers. They're just arranged differently. However, when we add them all together, we always get the same answer, right? 3 plus 4 is 7, plus 7 gives us 14. So this would give us 14. And of course, this would give us 14. Right? Now, what does that have to do with math? That's where we get what's known as the commutative property of addition. When you work with addition, commutative property says that it doesn't matter which order the numbers are in. As long as you add all of them together, you're going to get the same answer, right? Even though the order was different here, here, and here, we always got the same product or the same sum. And so in the end, you have the same answer. And so that's what the commutative property is all about, the fact that you can kind of do math in any order. Right? How does that help us? It kind of helps us when it comes to grouping. Right? When you look at this problem here, we say, okay, 4 plus 5, all right, that equals 9. And then 9 plus 6, that equals 15. And then 15 plus 5, that equals 20. So we get an answer of 20. And while that math is not the most challenging math in the world, it's not necessarily the fastest way to do this problem. Because of the commutative property, I can actually group my numbers a little bit differently. All right? As I look at this, I look at 5 plus 5 and say, wait, that's 10. That's easy. And then I can look at 6 plus 4 and say, hey, wait, that's 10 too. And so 10 plus 10 equals 20. And so in this method, by grouping things differently, because you can, because of the commutative property, you're able to add these things together and get a sum just slightly faster than the other way, which of course is to your advantage. Now, when we add things, it's going to come in word problems too. We see this example. Jared had $462. Sally paid Jared $58 in rent. How much money did Jared have now? So we have these 2 numbers up here that we want to add together. So the key thing we want to do when we add numbers together is make sure that our place values line up. Our 2 is our 1's place value, and our 8 is our 1's place value. So we're going to make sure our 8 goes right underneath that 2. Just like the 5 is in the 10s and the 6 is in the 10s, so we want to make sure that 5 goes right underneath the 6. And now, since these are all our digits, we can add them together. 2 plus 8 gives us a 10, 0 goes down, 1 goes up. 1 plus 6 gives us a 7, plus a 5 gives us a 12, so 2 goes down, 1 goes up, and 1 plus 4 gives us a 5. Put our label on there because it has one, and we have an answer of $520 is the amount of money that Jared now has. The last idea is quite an easy idea. It's called the identity property of addition. The identity property of addition states that when you add a number to 0, the answer is always that number. For instance, 3 plus 0 is 3. 16 plus 0 is 16, right? So when we're adding a number to 0, it's always the other number. That's going to be your answer. So when you get to this last one, holy cow, that is a big number! 289,897,000. But when you add it to 0, you still have 289,897,000. All because of the identity property. All right, here's some samples to get you on your way as you work with adding whole numbers. That's lesson 6.